This is America in Space, a weekly news and information program on current events dealing with the space industry.
Welcome, and thanks for joining me today. I'm Dawn Meyer, Space Coast News Editor. The launch of the Polaris Dawn mission has been delayed until no earlier than Friday, August 30th at 3:38 a.m. due to unfavorable weather conditions forecast for their splashdown area off the coast of Florida for the planned return from space 5 days later. In a statement, Mission Commander Jared Isaacman elaborated on why their launch hinges so much on the weather nearly a week from now. He said, "Our launch criteria are heavily constrained by forecasted splashdown weather conditions. With no ISS rendezvous and limited life support consumables, we must be absolutely sure of re-entry weather before launching. As of now, conditions are not favorable tonight or tomorrow, so we'll assess day by day. As Elon mentioned, Polaris Dawn is a challenging mission with critical objectives, so we'll wait for the best opportunity to ensure success. Sometimes the hardest journeys require the most patience, and we're ready to wait for the right moment." Here is Isaacman with the details of the mission.
We're flying on booster 1083, which will be its fourth flight. We'll be flying on Dragon 207 on its third flight. This is, if you know the history of it, this is what Crew 1 went to space on. This is what I flew on previously for Inspiration 4, and now Polaris Dawn will go on, which is pretty cool. Very low-time Dragon, which is nice. We will launch from 39A. We're expecting up to a 5-day nominal mission duration. We will launch into a 51.6 degree inclination and an orbital period of approximately 106 minutes, and that does vary based on the altitudes that we will be going to, which brings us to the next point here. We will Falcon will drop us off in a 190 by 1200 kilometer initial orbit. At that point, we will check out the Dragon, make sure it's very, very healthy. We will pass through the South Atlantic anomaly, and then we will raise apogee up to our peak, which is 1,400 kilometers. That should surpass the Gemini 11 record. And then after approximately 10 hours, we will lower apogee to about a 190 by 700 kilometer orbit, and from there we will remain. We'll conduct our EVA before eventually phasing down and re-entering and splashing down either in the Gulf or the Atlantic. Now we do have 3 launch T0s. We will eventually down select the day of the launch. The window first opens at approximately 0330 on the 26th and goes to approximately 0700. Now, you know, when you go higher into space, that comes with all sorts of potential challenges. You're putting a lot of energy into a vehicle, then you take it out. But there's other realities when you're up there too, which is a completely different micrometeorite orbital debris environment, obviously a different radiation environment. We'll talk a little bit about that. But Earth does a really good job as objects get closer to it to clean them up and burn them up, but that takes a really long time when it's higher up. So a lot of smart people at SpaceX figured out the optimal times for us to launch, which is why we have that launch window, and through vehicle pointing, so the attitude we're flying at, and then that low 190 perigee, we're able to mitigate a lot of that orbital debris risk during those launch windows. So then just to take you through the Polaris Dawn main mission objectives. So our first objective, which should take place during the first day on orbit, is an altitude record. So again, we'll go up to 1,400 kilometers. This is the farthest humans have traveled since the last time humans walked on the moon more than 50 years ago. And 2 of my crew members, Sarah and Anna, will be the women who have traveled farthest from the Earth ever, which I think is pretty cool. Now, why do this, right? As I mentioned before, when you go into this environment, you're dealing with totally different realities than, for example, when you would go to the space station. So again, it's a lot of energy going into the vehicle. It's a lot of energy to take out of the vehicle when you come back home. It is a different radiation environment. It is a different micrometeorite orbital debris environment. And we stand to learn quite a bit from that in terms of human health, science, and research. If we get to Mars someday, we'd love to be able to come back and be healthy enough to tell people about it. So I think it's worthwhile to get some exposure in that environment. Also, it informs vehicle architecture because generally speaking, vehicles don't like radiation. So that's why we're going to stay there for the shortest amount of time that's necessary to gather the data we want, and then we'll come back down. Our second major objective is the first commercial spacewalk. In this case, we'll take you through it a little bit, we are going to vent the vehicle entirely down to vacuum. There is no airlock on Dragon. That means all 4 crew members are exposed to the vacuum of space. 2 will remain inside the vehicle, and 2 in sequence will go outside the vehicle. When we are out there, we're going to make use of various mobility aids the SpaceX team has engineered, and it'll look like we're doing a little bit of a dance. And what that is we're going through a series of test matrix on the suit, and the idea is to learn as much as we possibly can about this suit and get it back to the engineers to inform future suit design evolutions. And we do that. We're super proud, knowing the massive amount of effort that went into making these suits, and just shortly Sarah is going to take you through what that development process is like. But it's not lost on us that might be 10 iterations from now and a bunch of evolutions of the suit, but that someday someone could be wearing a version of which that might be walking on Mars, and it feels like, again, a huge honor to have that opportunity to test it out on this flight. So we will learn as much as we can about that suit. The entire operation is scheduled to be about 2 hours from venting to repress. We're building a lot of margin there for anything unexpected to go on, but actual out of vehicle time, could be somewhere in the neighborhood of 15 to 20 minutes each while we're out there. Next, our third objective is we are testing out a new communication system. This is using Starlink laser links. So there is a placer that is mounted in the trunk of the vehicle that we will be flying on, and through beams of light it will communicate to other Starlink satellites. And this is pretty cool. It is no small task to have 2 objects going 17,500 miles an hour communicating over a beam of light, but it has the opportunity to open up an entirely new communication pathway, not just for Dragon, but for armadas of starships or other satellites or telescopes out there, and kind of free up some of the burden on the existing TDRS and ground station infrastructure. And then we will, as I mentioned before, use every bit of the time in between approximately to accomplish approximately 40 science and research experiments.
The astronauts must pre-breathe oxygen for 2 days to purge as much nitrogen from their bodies as possible for the spacewalk, which is why consumables are limited. So we'll just have to wait for good weather. Thank you for joining me, and thank you for listening from your home or where you work. And wherever you listen, be sure to like and follow us. Listen each Tuesday for This Week in Space with John Gomez. And join me every Friday for America in Space. From the Florida Space Coast, I'm Dawn Meyer, Space Coast News Editor for About Space Today.
Thanks for listening. Be sure to share our program with your family and friends, and follow us on Facebook. Join us each week for news and information on America in Space.